Welcome to the Futurist Society podcast, where we delve into the latest advancements in technology, science, and culture. From discussions on the latest breakthroughs in AI, biotechnology, and space exploration, the Futurist Society is your window into all of the awesomeness that the future holds. Get ready to be informed and inspired as we consider the positive impact of emerging technologies on humanity. Without further ado, welcome your host, Dr. Awesome.
Hi, everybody. Welcome back to the Futurist Society, where we are talking in the present, but talking about the future. Today, I'm really excited. We have Kevin Murphy, who's the Chief Data Science Officer for NASA. And he's done a lot of really cool things with all of the information that NASA produces on a general basis. So, Kevin, tell us a little bit about yourself, how you got to where you are, and kind of what you're doing right now.
Yeah, thanks for having me. I think this is a great opportunity to discuss, a lot of the things that NASA's doing. And you obviously have a really, really interesting podcast here. So my name's Kevin, as you already heard there, but my responsibility is today to manage and to help manage all the scientific data that comes from about 150 or so missions and instruments that NASA launches into space. That data is an incredibly vital resource for understanding new scientific areas, but also monitoring our climate and our planet, looking beyond our solar system to the distant galaxies and understanding what goes on here at home. So, I started this job about 3 years ago now, and I originally came from an earth science background, where I used data to do land cover remote sensing, which is basically looking at how forested areas change, how deforestation occurs, where it occurs, why it occurs, and kind of what the impacts are on the climate. So, I think NASA collects a lot of really interesting information. And I think a really cool part about what NASA does is that they make all of that data freely and openly available. And we've been doing that for a long period of time. Because what we need are a lot of people to be able to look at that information, make new discoveries, and be able to make decisions, especially when we talk about earth science information.
So, Kevin, one of the things that we had talked about a little bit was just the amount of data that NASA processes. And I think that the term was petabytes, correct? P-E-T-A?
Yeah, petabyte.
I'm sorry. So give me an idea of how much information that is. Like what is the quantifiable term for like a real world understanding? Like, are we talking about, like the same amount of data that Amazon processes, or like how much data is that?
So it's a lot of data, right? I mean, if you try to capture it in terms of libraries, there would be libraries covering the entire surface of the earth with that information in it. And this is really high quality scientific information. Now, certainly, in the commercial areas like Amazon has, or Netflix, or a bunch of other people, they collect a lot of information too. In many cases, they collect much more volume, but that data isn't necessarily scientific information. It is really about commerce. It's really about, what you spend and where you are and how you get better marketing. So yes, we have a lot of data. And it's very, very exquisite data, but it's also publicly available.
Mm-hmm. And it's difficult for an organization like NASA just to process that amount. And so you've kind of allowed the public to have free access from it. Can you name some instances where the public has really helped out in advancing scientific causes?
Sure. So, we launch missions primarily to collect information, right? Because we don't go to Mars. We don't go to the outer, planets of our solar system. So the primary deliverable of these missions that we launch, all of that engineering, all of the aerospace work, all of the communications activities that we do is to bring this data back. And we have really good ideas of what we think we're going to find with that information, right? So we develop a mission concept, and that mission concept might be like, okay, we want to go collect samples from an asteroid and bring them back. back to Earth for analysis. And we know kind of the basic things that we'll likely find in that information that we bring back. However, there are so many other things out there that people haven't discovered with that same information. So, you can use gravity measurements, for instance, around the Earth to actually understand how the water cycle works, right? And how climate change influences the storage of water in different areas. We didn't know that before. We launched the mission to do gravity fields, and then those gravity fields came back and they were like, why are they changing? And they said, oh, well, they're changing because you're moving mass in the form of water around the Earth, part of the water cycle. So that's one really good example. Other examples are things like citizen science activities, where we help categorize the types of galaxies by their shape using some web tools like that allow people to help scientists classify galaxies in ways that we couldn't do before. So, I think the big part about making our information public is that people with innovative ideas can come up with, new types of research, new types of applications that, we can't come up with internally to NASA alone. We don't have enough time or enough money to process all the data in all the different ways that, can potentially be done. And the community really helps us do that.
I think that, I grew up in Florida, and we went to Cape Canaveral, and I saw, the rocket launches and stuff like that. And people have this idea of NASA as like this all-seeing, all-knowing organization because of just the cutting edge technology that you deal with. But it's still such a small part of the US government that it's very easy to forget that it's limited by the amount of people and the amount of money that you're talking about. And the amount of information is just overwhelming. Like, one person would be lost in the amount of information that you guys are processing on a regular basis. So I do like the fact that you guys are opening it up to everyone. But what are some do you know of any real world examples where people have made some sort of breakthrough or have pushed the field forward based on the data that you guys were able to collect and freely distribute?
They happen all the time, which is part of the problem too. So, for instance, we have an early release program with the James Webb Space Telescope, which is where, the data that come down are immediately available to anybody for any purpose. And a team of international researchers took that information last summer, about 14, 15 months ago, and used it to make the first detections of CO2 in the atmosphere of an exoplanet, right? And so that's just amazing. Like, that happened. It was a huge team of international participation and local and domestic and all sorts of different people. They used, Slack to do their communications. They developed the software on GitHub, and they were able to collaborate across continents and time zones to analyze this information to do a new discovery that had never been done before with a brand new instrument. Now, I say that our products are freely and openly available, but they're also very sophisticated products, right? You're trying to do science with these things, and you could have spectrometers, and you can have, different types of measurement techniques, which take some skill to do. So part of what we try to do too is not only make our products open, but to provide the tools necessary to do some of that and some of the training as well, right? Because really you need to empower people to learn how to do this, right? It usually takes like a PhD or some sort of electrical engineering degree or something, to get the initial stuff together. But once you do that work, then you can make it more available to more people. You can provide them with, the data science techniques and tools that they can run either on their own computers or in cloud environments to process that information. So it's hard work, but it's also really useful work. We've seen other people use earth science information, for instance. So we have a mission called Terra, which was launched in 1999, and on it there's this thing called the Moderate Resolution Imaging Spectrometer, which is a really fancy way of saying it's a really good camera, and it looks at the Earth, the entire surface of the Earth, about once a day in the daytime and once a day at nighttime. One of the things it has on it are thermal channels, and those thermal channels can detect things like forest fires of a certain intensity, right? And what we've seen with that, for instance, is that people can take where it detects a fire potentially, and back in the 15 years ago or so, maybe 16 years ago now, we set up a service that said, hey, look, if we detect a fire, we will send people an SMS message for the geography that they're interested in, right? We got a lot of people from Africa, for instance, that were like, oh, wow, we can use this to help us fight these forest fires or land cover fires so that they don't burn down habitat, right? People can use this information, especially the earth science information, for agriculture, so they can look at water stress in plants. People have been using this information to look at air quality measurements. Commercial industry has used our measurement of chlorophyll A and B to evaluate, where they should fish in the oceans. So there are a lot of different use cases that we've seen out there. In earth science alone, I think we have about 3 million unique users of the data per year.
Wow.
So it's really hard to put your finger on just one single thing that people do.
Yeah. No, but it's nice to hear that that community is so large. I think that if you're a young kid and you get involved with this thing, it's nice to have other people that are doing it that you can talk to and stuff like that. It's always nice to be in a community of like-minded people. I think that that's what drives innovation forward. But honestly, what I really like is what everybody thinks about NASA as us looking out, but so much of it is also us looking on the Earth itself, right?
Yeah.
What I think is really cool is that we really didn't have that understanding 30, 40 years ago before all this satellite technology. Side note, is all of the technology that GPS is built on based on NASA information, like the topographical information when you're in Google Maps? Is that coming from you guys, or is that coming from private industry?
So there are a couple of different things in the kind of statement you made. The first thing is GPS is like a position, timing, and navigation system. That is launched by not NASA, but kind of by the military. That was a military technology that was really, really valuable for everybody. That's why we use it in our cars and everything today. In fact, we also use it on satellites. We use GPS receivers on satellites to figure out where they are in the sky. So, NASA doesn't do that. We definitely use it. It's a very important thing. And actually, I have a separate thought about GPS. I'll come back to that in just a second, because you can do some amazing things with it. But Google Maps, Google Earth, their kind of satellite overlay is actually an amalgamation or a combination of both commercial information and public information. So, when we look at the really high spatial resolution things, so you can see your car in your driveway, those are typically commercial products that they purchased that they can then display. As you zoom out,
you've launched into space.
Well, they may have launched them into space. Then as you zoom out, the higher level products, the products that are updated more frequently in terms of time, those are typically from government agencies like NASA or like our European partners at the European Space Agency. They have really, really good measurement techniques as well. But just to go back to GPS for a second. So, we all use GPS in our cars and to say, hey, how do we get to the next Starbucks? Which is great. It's definitely made our lives more efficient. But what we don't realize is that the signals from GPS, right? They can kind of go through the atmosphere and they can get kind of deflected and come out the other side of the atmosphere. And through special satellite antennas on very small satellites, typically, you can actually capture that information, and that information can tell you like incredible things that we never would have thought of when the first GPS satellites were launched. You can use it to look at soil moisture, for instance. You can look at the planetary boundary layer, which is a spot in the atmosphere which is important to how kind of the atmospheric mixing happens. You can look at sea ice freeboard, which is basically the height of ice above the water, like in an iceberg, right? So there are these amazing techniques people have been able to, develop based on information that was never thought that they could do it, right? And I can only imagine that there are just so many more of those types of discoveries to be made. Anyhow.
And so do you think that that's a function of just like our better understanding of that information now, or is it more like that sensor technology has rapidly advanced over the past like 10, 15 years?
Well, like GPS has been around, right? Since the late 80s or mid 90s or something like that. So it's one, our understanding, like you've got to advance a theoretical component, and then you've got to like go and test it in the lab and test it outside of the lab, right? So you've got to be able to do that. But a critical component of it is making that information open, right? Because there are so many people out there with potentially really, really interesting ideas. If you just say, hey, look, we have this expert group and everything that expert group does isn't shareable, you really lose a lot of the benefit of collecting that information.
So, we talked a little bit about this one particular aspect of NASA, and I think that there's 6 different divisions, correct? There's like a division.
There are 5. We got 5.
5, excuse me. Okay. Can you just tell the public about, or our listeners about all of those 5 divisions? Because everybody just kind of focuses on the ability to put people on the moon or, go to Mars and stuff like that. But you guys are doing a lot of stuff outside of that.
So maybe just a word first is that, NASA is all about discovery. Whether that's discovery of new engineering techniques, new aeronautic techniques, or exploration techniques to get people to go places, we're really about that. Within NASA, we certainly have our human spaceflight areas and aeronautics areas, but we also have this really large directorate called the Science Mission Directorate. And within the Science Mission Directorate, we have 5 divisions. Those 5 divisions look at a lot of different things. The one division looks at the sun. It's called the Heliophysics Division. And what they do is they look at space weather, they look at the sun, they look at how the sun evolves over time. Maybe you've seen the Parker Solar Probe in the news, and that's kind of orbiting the sun and getting closer and closer and closer until it reaches its fiery kind of death. And it's just making incredible discoveries about how that system works. And that's really important, right? Like the sun obviously is a very important star for us.
Literally the most important star for us.
I would say so, right? And it's my favorite too. But, I think not only does that really power how the Earth's ecosystems work, but it also will power how we explore, the solar system, right? You can look at different types of environments where the sun could be very dangerous to humans that are exploring, right? So we need to understand a lot of those dynamics. So that's the Heliophysics Division. We've got the Planetary Science Division, which looks at all of the planets in the solar system. Their job is to go and discover new things about Mars, about Venus, about Saturn, so on and so forth. And they send the rovers, right? So like if you've seen, the Mars rovers, those all come out of that division. We do lunar exploration as well with that. we have a thing called the BPS, or the Biological and Physical Sciences branch, and they look at kind of how human systems or biological systems change while they're in space, right? So we have experiments on the space station that they use to look at all sorts of different things, whether that's from growing plants to how mice do different activities. Then we have the Earth Science Division, which we've talked a bit about now, and that's the one I'm most familiar with. I worked there for many, many years before I took on this job. And they look at all the systems of the Earth and how they change and interact over time. And then finally, we've got the Astrophysics Division, which looks beyond the solar system. It looks at distant galaxies, their formation. People might know things like the Hubble Space Telescope or the James Webb Space Telescope as really big examples of those. And they're really pushing back our understanding of the universe to as early as we possibly can do.
So I would be remiss if I did not talk about a few of the hot topics that the internet is ablaze about, right? And so one of them, is the conspiracy theory about aliens and all of this other stuff that, is kind of in the news right now. And, in the UAP community, they're talking a lot about the fact that NASA used to look at the sea and the oceans, but then they stopped looking at it. I wanted just to get your take on that, because that's something that people think that is concerning, that there's sort of like, some spaceships under the ocean floor. You were in the Earth Sciences Division, you were taking a look at this stuff. So tell us a little bit about your take on all that.
Like I said, all of our data is freely and openly available. In fact, if you Google something called NASA Worldview, you can see the data that we collect every day in kind of like a Google Maps sort of format, okay? And that Google Maps format is updated every day. So if you're interested to look and discover that types of information, I would say go take a look. We have a lot of different missions that collect data globally, and some that point very narrowly to get higher resolution information. And it's all out there, it's all open, and we encourage you to use it. Worldview makes it a very, very easy format to view. Okay, you can pan, you can zoom, you can put, I think, 600 or 700 layers and overlay them together and see changes over time. And we certainly see a lot of usage of that tool, but just go take a look. It's just an incredible planet that you should be able to see where your backyard is, right? So go out there, take a look. I think that, if you find something interesting, let us know.
Are we looking at anything below the surface, though, of the ocean, or is it just mainly taking a look at everything that you can see from space?
So it's what you can see from space. It's hard to look underneath the ocean unless you're running a ship or a submarine. We're primarily a space-based agency. So there are other agencies that look at the oceans, like NOAA or the Navy and folks like that. But I think that we don't really look under the ocean too much unless we have very specific reason to do so. Which would be, if we're trying to monitor like glacial runoff and how that interacts with, the oceans, that kind of thing. I've got all sorts of dogs in my background.
Yeah, no worries. We can cut that part out.
Good.
Yeah.
We don't really look under the ocean unless we're really trying to understand like a physical process, like Greenland, where the ice sheets are melting, and there's a buoyancy between salt water and fresh water, which is changing kind of the circulation in that area. As far as I know, we haven't found anything there besides ice.
Well, it's crazy how popular this stuff is, right? And I think it's a good and bad thing, right? It's good in the fact that it gets people jazzed about science and our place in the universe, and they look at this stuff with a very fine tooth comb. They might have ignored it in the past. But I'm sure that, with the amount of public speaking engagements and stuff that you've had to do, you've had people come to you with like flat earth conspiracies or, stuff like that. That stuff is out there on the internet, and I think that it's people like you that are sifting through the data that need to start talking about this stuff, because that stuff is out there and it's not going away. On the other end of the spectrum, there's a lot of buzz about the mission to the moon that is coming up next year. I think are they still on track for that, or did they push it back? Is it next year, or is it
No, I've got to remember or look at exactly what the timeline is for that.
Yeah.
NASA.
Well, I saw the interview that the four astronauts that were selected did on one of the late night talk shows. And man, they are fucking impressive. Oh, excuse me, man, they are impressive. We can cut that part out too. Man, they are impressive, and it was so awe-inspiring that I just like started crying, I was so happy that we were going back to the moon, but also that like these were the people that were leading it.
Yeah.
What are you doing in preparation for that? Because the amount of data I'm sure that you're going to be getting back from that is going to be huge, and you don't want any hiccups.
So we have a portfolio of activities going on related to the moon. Of course, one of the big ones, the ones people see, is like the Artemis launch. And I think next fall, there's going to be a test flight with astronauts to go around. I think that's supposed to be about a 10-day mission. So, we're actively preparing everything we can to do that. And that's a lot of engineering testing, although there will be some opportunities for some science. We're also working with commercial industry to launch scientific payloads to the surface of the moon, to look at all sorts of different things, and also to test out how we work with commercial industry as we make that next step. So yeah, we'll have a lot of data from the moon, but what you might not know is that we already have a lot of information from the moon. We have this one measurement or instrument called the Lunar Reconnaissance Orbiter, or LRO, and it has been orbiting the moon for I don't even know how long, but over a decade. And it's got very high resolution cameras on it. It's got LiDAR techniques, which allow you to do topographic information. And in fact, when they launched it, and you might want to go back and take a look at this, it's basically a camera, and it had a booster. I can't remember if this is the right term. It's been so long, but you have to boost it out there with a second or a third stage. And what they decided to do was crash the booster into the moon, so it would come up with a dust plume, and then they could use LRO to image that dust plume to see what the composition of the dust was. So they
LRO is LiDAR, or
it's got a couple of different instruments on it.
Okay.
I think it has a LiDAR, maybe it's a radar, and it's got a spectrometer, I think, on it. So they were able to crash it in, point the satellites orbiting. They were able to launch this thing in, have the satellite in the right position to see it illuminated by the sun, and then take an image of it so that they can see the mineral composition of the dust.
So that's it in orbit right now, and that's freely available to people that they want to look at. Yeah.
Yep.
And can you see the light side of the moon and the dark side of the moon, or is it just the light side?
So I think it's just the light side of the moon. I don't think that there's like a lot of the instruments we have are what we call passive instruments. So they don't have their own energy source, kind of like a camera versus a camera with a flash. So we don't really have a giant flash on big part of that.
Because power would be an issue when you're dealing with something that's going to be on the surface or in orbit for years and years and years. Yeah, totally understandable. So, the other thing that, I wanted to talk with you about is just, all right, you have all this data coming in. There's so many different things happening with like artificial intelligence and machine learning and stuff like that. Are you guys leveraging that to sift through this data right now?
Absolutely. And we do it in a lot of different ways, some of which are interesting to external people and some which are interesting to the internal people, right?
Mm-hmm.
So I think, artificial intelligence has kind of ebbed and flowed for the past 30 years.
Mm-hmm.
Um, you know, I guess about 10, 11 years ago, there was a really, really big push to machine learning and deep learning.
Mm-hmm.
And that was critical for us. We were able to use those techniques to do things like monitor and find dust in different imagery, look for similar types of forms in imagery. The problem with it was, or even like estimate hurricane intensity quickly, like much more quickly than from imagery taken of the hurricane than you could do through modeling runs, right? So we could estimate within pretty reasonable accuracy within about 15 minutes of the data coming down what the hurricane intensity would be. The problem with all those techniques was that they took an immense amount of training data, just immense amount of typically human curated, although sometimes there were machine curated training data sets, like thousands and thousands, tens of thousands of things, all labeled properly. Over the past 3 or 4 years, though, there's a technique called transformer architecture that you may or may not be familiar with, but it's a thing that really powers the large language models now. So if you think of ChatGPT or Bard or any of those big ones, that's the underlying technique which allows it to do the work. So in language, you kind of give it a whole bunch of sentences, and then you say later, hey, can you tell me what the next word in this sentence should be? And then it generates a word, right?
Yep.
It turns out you can use a very similar type of technique, although it's slightly different, to look through geospatial data, to look through basically stacks of images taken of the same place at the same time of day over subsequent days. And you can use that with smaller training data labels to actually parse through that information really, really quickly. Right. So let's say you're interested in flooding in Arkansas. Well, you can develop a model over all of the United States, and that model, once you kind of run it through machine learning and AI capabilities, you can then use a small amount of training data set and like identify floods over the entire US at different time periods, right? So it really speeds up the ability to process that information, and it does so in ways that we didn't think were possible, right? So every 4 days, we, with our partners at ESA, image the Earth at 30-meter spatial resolution. So that's kind of like looking at the field scale, right? Of you're not really going to see an individual house, but you'll be able to see neighborhoods, you'll be able to see roads and those types of imagery. And we do the entire landmass of the Earth every 4 days at that spatial resolution.
Wow.
And it's a lot of data. It's
terabytes. So trends that are being picked up, like let's say, for example, you work in deforestation, right? Are there some trends that you could tell us that might make us hopeful for the future? Because I feel like so much of how we look at the environment right now, especially, is so negative. I think that everybody thinks that we're going on this downward path, but I look at like they're cleaning up the Pacific garbage patch. We have this new focus on deforestation in general. Like I think that people have much more environmental consciousness now than they've ever had in the past. Certainly, like from when I was growing up, there was a time when like recycling wasn't even available. And so what are some trends that you're getting from all this data that might make us a little bit more hopeful about the future?
So, I think one of the trends is that, is that people now have access to information they didn't have access to before, right? They've got it at scales, and I mean that like backyard scales, right? So they can start to use this information in their decision-making process. They can start to see how they might be able to adapt or mitigate those activities that they're vulnerable to, right? Or move, or change infrastructure, or build better buildings. These are all things that are facilitated by collecting information, right? So, I think the most hopeful thing I have is that we have people that are now really interested in this. We have people that have access to this information, and they're trying to come up with incredible ways to deal with it, whether that's making us more efficient, better planning of where we put things, better management of the resources that we have, right? That better transparency into what people are doing. So I think that those trends are incredibly important. I think also the recognition that there needs to be equity and access, and diverse input into how we make those decisions is also very encouraging. So, yeah, I think I think the future is very bright with this.
I like to think of it that everybody has in their pocket the entire capability of knowledge that has ever come before. So like if you wanted to like start up a garden, you can have like a to-do list of things to do for your garden and make it fruitful on your first attempt, right? And so that to me gives me a lot of hope. I think just the ability to scale any sort of knowledge-based application up very quickly is very, very significant. I don't think that we've really had that in the past. Like, when I was growing up, we had to go to the library if you wanted to learn something, right? And I don't think that the internet was as accessible as it was now. Now my 2-year-old can talk to the internet and learn something from it. But, I'm really interested in seeing what the data for everything shows us. I think that up until now, we've had the ability to collect data, but it's only now that we're having the new technologies available to us to sift through that data and actually gain insight from it, which I think is going to be really cool over the next 10 years. We are getting close to our time, so I did want to ask you the 3 questions that I ask all of my guests, because we kind of went down a few different fields, but the first thing that I always ask is, where do you gain inspiration from? Because I feel like for me, it's science fiction. I look at things like Star Trek and having this utopian vision of the future. It's something that I really want to enjoy. Like, I want to live in a future where we have robot butlers, or we have food for everyone and stuff like that. But where do you gain inspiration from?
So I am a big science fiction fan as well. I really that, but I think a lot of my inspiration actually also comes from the environment. Avid sailor, I like to camp and hike and fish, and I think that really brings home to me like how important the environment is, and how we need to be sensitive to it. And I really like to marry kind of the technical aspect of the work that we do with the grounding in, the places I find valuable. So I think it's that marriage that really makes it happy for me. And that's where I got my inspiration and kind of recharge from.
I mean, being in the data science field, have you read like cyberpunk or any of the cyberpunk genre or anything like that at all?
Yeah, a little bit here and there. I've read I can't even remember all the books now. A lot of what are
the reason why I'm saying this is like
it's good. I like that, and
the reason why I'm saying it is because there's this future that they envision where data is freely available. There's no privacy anymore. And it's not necessarily a bad thing. It's something that gives people a lot at the ground level, a lot of access to things they otherwise might not be able to, and especially with you dealing with data science. I feel like there's two schools of thought when it comes to data. Is it like it should be hoarded or it should be given away freely? And I think that based on everything that you're saying, that you're very much of the camp that it should be given away freely, you know? And
I think, yeah, I think for the vast majority of the information that we collect scientifically, it should be given away freely. I think, though, that there are really significant, data privacy questions as well, right? Like, I don't want all my medical information being given away freely, or DNA information or what have you, right? Or tax information.
Right, right. Within reason.
Yeah, within reason, we need to make sure the data is open and available. And if you have any good book suggestions, I'm happy to take them. I'm always looking for stuff.
Yeah, we'll talk after, and I'll give you some good things that'll blow your mind. So other things another thing that I wanted to talk with you about is that, okay, from a macroscopic view, I feel like this is the time to be at NASA, right? Like 1960s was like a really exciting time. We're going to the moon, we're doing all this stuff. And then it kind of like lost popularity for a while. But now, especially with you guys going back to the moon, there's like this huge buzz. Do you feel that like on a daily basis? Like, or like the scientists, like, do you see that kind of excitement now as opposed to maybe like 10 years ago? I feel like from the outside I see that, but I don't know, like you living into the office, are you experiencing that excitement as well?
So one of the coolest things I get to do is go out to the NASA centers or go out to the community and talk with them and work with them. And the buzz is real. People are excited. People are doing hard work, and they're really motivated to do it. NASA has always had a really, really good mission, and it's really excited a lot of people. So if any of your listeners are interested in like a really dynamic and difficult but rewarding career path, I think there's so many different opportunities at NASA. They should just come and apply.
Yeah, I mean, I look at the first space race as something that just had such profound effects for society at large. Neil deGrasse Tyson has this like interesting talk about how even like the fins of the rockets trickled down to the cars, and it permeated the public consciousness. And I think that we're on the verge of like that moment again with like the next one. So I feel like it would be an exciting place to work in the same way that like, my friends who live here in Cambridge, Massachusetts that are graduating from MIT, like they want to work at Tesla, they want to work at SpaceX, they want to work at Amazon, all these different companies that are just changing society as we know it. I feel like NASA's on the verge of that too. You get somebody on the moon again, you get the whole world watching it again. I think it's going to be like a really, really fun and exciting company to work for. So last thing, I ask everybody this is like, where do you see NASA in 10 years? Hopefully we're on the moon. What else is down the pipeline that you hope to see happen?
So I think that there's a lot that we can still learn at NASA. And from the Science Mission Directorate side, I hope that, we have a lot of new missions that help people understand the Earth better. I hope that we discover more about the moon and Mars. I hope that we make the next giant discoveries about the origins of the universe, and I think we will. We have people, we have the capabilities, and we have the support throughout the community to do that. I think within data science specifically, though, I think it's going to be a lot easier for people to interact with petabytes or potentially exabytes of information, which is just incredibly large amount of data. And I think you're going to be able to do that through natural language prompts in interaction. Right? I think we'll have a more equitable and easily accessible set of Earth science information, planetary science information, heliophysics information that people can interact with and really tailor it down to their local needs, right? Or their specific questions.
So NASA aside, like where do you see data science in 10 years? Because you have all these visions of the future, like you're gonna have your own personal assistant, right? That curates your life for you. You're gonna have other, views of, AI being this overlord that, treats us like sheep. But I think I'm pretty excited about all of the different applications for the data that's going to be coming. Like, I would love for my own life to be looked at the way that you guys are looking at the world, and knowing the exact amount of calories that I'm taking in, so I don't have to log it on my phone, or the amount of liquid that I've drank to make sure that I'm at my proper hydration levels. And hopefully an AI can manage that. So where do you see data science in 10 years? Like, is it going to be something like that, or is it going to be some sort of other version of the future?
I think that we're going to get more and more information, and we're going to be really interested to see how we can make it work to better our lives and increase our knowledge. Like I've got a watch that tells me a lot of stuff, but I can't wait until it tells me more. And maybe it will also tell me like, hey, you've been outside too much, or the air quality's too bad. It's time to go. I think data science is going to be able to put those pieces together. And really allow people to have more agency over the decisions that they make, and understand the impacts of those decisions. I think, ultimately, if data science works out properly, driving will be safer. Maybe the amount of work that we have to do will be, productivity will be increased substantially. And I already see that with some people. Like, I don't know, I've got a teenager who uses ChatGPT maybe a little too much for school, but I think it actually teaches him how to think sometimes too. So we've got to be careful that we don't have too much bias in those types of systems, but I think we have to embrace them as well, right? Because that is the future. The future is more information at your fingertips to make better decisions.
I think that's a great sentence to leave it on. So thank you so much for speaking with me, Kevin. And thank you so much to everybody who's listening. Please like and subscribe. And we will see you all in the future. Have a great day, everybody.
Thank you.
We appreciate you taking part in today's episode. Take this chance to reimagine a better future by joining a community of futurists who strive for a remarkable world. Be a part of this growing network and contribute to making the world a more positive place. Visit thefuturistsociety.net and subscribe to the show so you don't miss a drop of hopeful futurism.